All right, guys. I'm sorry I'm not here today. I am on a field trip, but I will be back Monday. And please don't forget, you have your quiz on angle of the sun and hours of daylight on Monday. And I'm going to go over a little bit of a review on that today. Today's learning objective: understand that there are three ways for heat to be transferred on Earth. You will watch an Ed puzzle on this, and hopefully it will help out and make sense. And then you will see that convection is the most important for weather and climate. And that's the unit we're getting into, is on climate. Okay. We'll go through the things that you need to do. The quiz review, I will go through a review for you here in a minute. Then when I'm done, you should get the Ed puzzle done. It's on heat transfer. Then there's a heat transfer practice sheet. Not all of it that you're going to do. I'll kind of go through and kind of explain how you do the sections, but there are a few questions that you're just not going to be able to do right now, and we'll do when I get back. And then this annual weather graph is just interpreting a graph and answering questions from that. And so there's still a few of you that have not resubmitted or submitted in the first place your wind turbine lab. I am getting back to those, but I'm getting a little behind. So I will get your resubmissions graded here shortly. The Ed puzzle should be done in class today. It's only like a 7.5 minute video. And then the heat transfer sheet and the annual weather would be due for next time. Okay. For the warm up, if the direct rays of the sun are here, that's north of the equator, and that is going to happen in June, June 21st, our first day of summer is when that will be. And that was when we're having our longest hours of daylight. So your answer would be right here, June 21st and longest. Number two is something you're going to have to do, and that is to determine the hours of daylight. And so remember, you measure from the terminator all the way the lit side. So if I look at the ruler here, it looks to be about 2.6 or so. And then I'm going to measure the entire distance, which looks to be about 4.2. If I do 2.6 divided by 4.2, and then multiply that by 24, I get a number very close to 15 hours. And so that would be my answer there. For number three, this is what we worked on last time. You're going to do the altitude, or the angle of the sun is 90 minus latitude and then plus or minus declination. And then on September 22nd, that's an equinox, meaning the direct rays of the sun are on the equator, which is 0 degrees. So there will be, your declination is 0. So you're just going to do 90 minus latitude. 90 minus 40 is going to give 50 degrees. Okay, so that's that one. And then here on December 21st, the direct rays of the sun are south of the equator. So we're going to subtract, because it's going to be south of the equator, and we're going to subtract 23.5. So we're going to do 90 minus 55, which is 35, and then we're going to subtract 23.5, and that's going to give 11.5. So it's going to be this bottom one here. Okay. You will have to do these sorts of things on the quiz. So if they don't make sense, go back and watch this video and see if it makes more sense. Okay. The goal for today, we already done the warm up and the learning objective. The Ed puzzle will be your first order of business. I am going to go over a review for the quiz right now. And then you have the heat transfer sheet and annual weather sheet as well. Okay. So real quick, you are going to be responsible to know what these locations mean. Not necessarily now. I'm not going to say, oh, what is the Tropic of Capricorn? You have to know that one's south. But I do think it's important that you note that any point above here will get 24 hours of daylight at some point and 24 hours of darkness at some point. Any point below here will get 24 hours of daylight and nighttime. These lines, the tropics, represent the furthest north in the case of the Tropic of Cancer, and the furthest south in the case of the Tropic of Capricorn, of where the direct rays of the sun are. They are on the equator, on the equinoxes, which is the first day of spring and fall. So here you have the first day of summer, first day of spring and fall, and first day of winter. Okay. Coming over here, remember we did this with the globe where we moved it around and we noted that the axis of the Earth was always pointed in the same direction. And because of that, as it moved around the sun's direct rays were either north of the equator or south of the equator or right on the equator over here. So I can show that better with this simulation. And so that dot right there represents where the direct rays of the sun are. And it shows it here directly on this green line, which is the equator. And as it moves around, you can see that now the direct rays of the sun are south of the equator on the Tropic of Capricorn. As it continues to go around, now the direct rays of the sun are back on the equator. As it continues in its way around, now they're up here on the Tropic of Cancer. I'm sorry. This is our first day of summer. And then back to here where they're on the equator again. And so over here, as the direct rays of the sun are moving to the south, we're moving towards winter, which is here. And then we're coming to the spring. It's moving north, continuing to summer, and then it will start moving south again as we go to fall and then back to winter. Length of the day. You can see that as the Earth rotates here, days are going to be short here and nights are going to be long. That's our winter when the direct rays are south of the equator. As it moves this way, we get to equal hours of day and night when the sun's direct rays are on the equator, and that's our equinox. And the days are going to get longer for us as we come this way. And you can see over here, more time in the daylight, less time at night. Summertime, our long days are more direct rays of the sun. Okay, so I hope that kind of makes sense to you. Coming over here, again, using this formula, 90 minus latitude plus or minus declination is going to give us our angle of the sun. So kind of showing that here, there's like a challenge question. What is the latitude of the location below? And you're given the angle of the sun at different times. What I would do is focus on the equinox. On the equinox, the angle of the sun is 40 degrees. 140 degrees measured from north, but measured from the south, it's 40 degrees. So if we remember, 90 minus latitude gives us the angle of the sun. 90 minus what gives us 40? The answer is 50 degrees. So this would be at 50 degrees latitude because 90 minus 50 gives us the angle of the sun, which would be 40. So again, kind of going to that formula right here, I'm going to kind of show you right here, and I'm going to have to use my pen here. These dates right here, these are the equinoxes. You just do 90 minus latitude, okay? When I'm coming from here to here, I do 90 minus latitude, but December 21st is the first day of winter when the sun's direct rays are south of the equator. So I would subtract 23.5. Coming over here, our first day of summer on June 21st, I would add 23.5 because the direct rays of the sun are north of the equator. So if I did Finland here, I would do this one right here first, 90 minus latitude. So if I do 90 minus 65, which is the latitude, I get 25 degrees. So the answer here is 25 degrees. When I go to December, I'm just going to take that 25 and I'm going to subtract 23.5 and I'm going to get 1.5. When I come from here to June, I'm adding 23.5 to 25. So I'm going to have 48.5. Okay. If I did Indonesia, I'm going to skip Denver. I did that in the review last class. So on Indonesia, 90 minus latitude. Well, what's 90 minus 0? It's 90. And that should make sense because it's on the equator. And at the equator, the direct rays of the sun are on the equator on March 20th and September 22nd. When I go to the declination over here, I subtract 23.5. So 90 minus 23.5 is equal to 66.5. So still pretty high, even on the first day of winter. Coming over here, this is a little bit confusing. I'm going to add 23.5 to 90, and I'm going to get 113.5. All that means is that the sun is on the northern side. So if I were in Indonesia, I would look to the north to see the sun, and it would be 66.5 degrees above the horizon above the north. This one is 66.5 degrees above the horizon to the south. But you can just record it this way, and just know it's still really high in the sky. Okay, I hope that kind of makes sense. Coming over here, I wanted to kind of go through again. This right here, all this shows is why it is hot at the equator and cold at the poles year round. If you look at the rays of the sun hitting on the earth here, because the rays here, as they hit to the north, they get spread out. That same amount of energy that is in each one of these rays. If I look at the width of each of these rays, it's the same. So the energy becomes more concentrated when it hits at the equator, and it gets more spread out when it hits at the poles. So if I look at that same thing kind of shown here, this is A right here. This is B, and this is B. This is C, and this is C. And so here at C, you can see it gets really spread out. The same amount of energy spread over a greater area means it's going to be colder. Okay. So how does the amount of heat in the beams compare? It's the same. How does the area covered? Well, C has the most area. You can see it here. And A has the least area. And that's why it's hotter at the equator. Okay. And most of those questions go along that. This over here, at what latitude is the sun hitting most directly? You look where it's hitting at a 90-degree angle, and that happens at 15 degrees north latitude. So right here, it's hitting at 15 degrees north latitude. The date is May 1st. So what calendar month? It tells you it's May. What would the latitude range for the area that is receiving 24 hours of daylight? So right here, 5 degrees north and north of that. So 75 to 90 degrees is getting 24 hours of daylight. Down here, that's 20. Well, that was a terrible drawing. That is getting 24 hours of darkness, if you can imagine that as a straight line. How many hours of daylight is 30 degrees north receiving? You would, again, measure from the terminator at 30 degrees north, right here. You would measure the length of that line, and then you would measure the entire length, divide this length by this length, multiply by 24, and that would give you your answer here. I can visually see it's going to be more than 12 hours because it's 12 hours at the equator. Anything north of the equator is more than 12. Anything south of the equator is going to be less than 12. Okay. I meant to do, sorry, over here. I wanted to go over. Sorry. No, I'm going to come back. That's the review basically. Now I want you to work on the Ed puzzle. It's a 7-minute, 53-second video. Answer the questions. And then you're going to do this heat transfer sheet. But the first part of the heat transfer sheet, we talked a bit about this last time, the difference between weather and climate, and it's going to ask some questions about that. So please know that the difference between weather and climate, weather is at any given time, the state of the atmosphere at any given time. So a tornado with lightning, that's weather. This would be climate. That in the North Pole, there is going to be always ice because it is always cold. It is an average of weather. Okay. So as you go forward and do the heat transfer sheet, that first section is asking about that. The summers here are hot and dry. Do you think that's weather or climate? So you're going to do that. I am going to show it from here. So that's what you do there. This you will learn that convection is heat transfer through motion. Conduction is heat transfer through touch. And then radiation is heat transfer through light. Okay, so frying an egg. The egg is touching a hot pan. That would be conduction. Okay, so you'll fill that in. Skip for now number 14 and number 15. You don't need to do those right now. We'll do those when we get back. You're given here the formulas for how to convert from one temperature to another. So for this one, going from Fahrenheit to Celsius, I would use this formula right here. It'll tell me what my temperature is in Celsius when I have Fahrenheit. So I would just replace that degrees Fahrenheit with the number 50. Remember your PEMDAS, or your please excuse my dear Aunt Sally order of operations, 50 minus 32, and then times 0.55 will give you your answer here. Okay, and then you'll try to convert to Kelvin. If you're struggling with this, do your best, and we'll go over it when I get back. And then skip this whole section down here. I'll go over that with you when I get back. If you can do these, great. If you can't, hold off, and we'll go over it when we get back together. But these right here, it is critical that you get these done right here, and you should be able to get these done right here. Okay. Then you're going to go to the annual weather graph, and you're just going to look at the graph. It tells you that these red dots are the high temperature, the blue stars are the low temperature, and then the amount of sunlight is this here in green. And then you're just going to use that to try to answer the questions. Okay. Hopefully you have enough to do, but it's not too much to do. And again, focus on the Edpuzzle and then on the heat transfer sheet. And then if you have time, work on this right here. Okay. I hope you have a great day, and I'll see you guys on Monday when I get back, and know that we're having the quiz on Monday. Have a great weekend.